Hey everyone, and welcome. So, I'm willing to bet you've heard the word blockchain tossed around everywhere. It's tied to crypto, the future of money, even digital art. But what in the world is it really? Well, today we're going to cut through all that noise and get right to the heart of this amazing technology. Let's jump in. Okay, so let's start with a big question, a really fundamental one for our digital world. How can you possibly prove that an online transaction is real, that you can trust it, when there's no bank or government in the middle to vouch for it? This whole problem of digital trust, that's exactly what blockchain was built to solve. And this is the solution. At its core, a blockchain is just a shared record book. Now, there are a couple of key words you're going to hear a lot. Decentralized, which means no single person or company is in charge, and unchangeable, or what people in the space call immutable. It's a system that lets people interact securely without having to know or trust each other, because they can both trust the system itself. Pretty cool, right? All right, so here's our game plan to wrap our heads around all this. First, we'll cover the basics of what a blockchain is. Then we'll look at the different types out there. After that, we'll get into the rules that make it all work so smoothly. Then the fun part, seeing it in action in the real world. And finally, we'll get real about the challenges it still needs to overcome. So let's dive right into part one, the absolute fundamentals. We're going to break down how this whole digital ledger thing actually works, piece by piece. You know, the best way to picture a blockchain is to imagine a digital notebook. But here's the twist. Instead of one person owning it, everyone in the entire network has their own identical copy. And here's the kicker. Once a page is written, it can never, ever be erased or changed. This shared permanent record is what gives it all its power. So how does a new entry get written into this special notebook? Well, it happens in a few key steps. First off, someone requests a transaction, and that request gets blasted out to everyone on the network. Then it gets bundled up with a bunch of other recent transactions into what's called a block. Next, the whole community of computers works together to check and validate that this new block is legit. And once it's approved, it gets cryptographically locked onto the end of the previous one, forming a chain. And there you have it. That's literally where the name blockchain comes from. Okay, so we've got the basic idea down. But here's something really important to get. Blockchain isn't just one single thing. There are actually different blueprints designed for different jobs. So let's check them out. You've basically got two main flavors, public and private. Think of a public blockchain like Bitcoin or Ethereum as a public park. Anyone can come in and play. It's totally open, transparent, and decentralized. On the flip side, you've got a private blockchain. This is more like a private office building. It's controlled by one company, and you need a key card to get in. This makes it way faster and more private, which is perfect for a company's internal operations. And that idea of who gets to join in leads us straight to another key difference, whether a system is permissionless or permissioned. A permissionless system, which is what you see with public blockchains, means anybody can jump in and help validate transactions, no permission needed. A permission system, on the other hand, is like an exclusive club. You have to be authorized, pre-approved to be able to participate. This is how private and consortium blockchains work. But what if you want something in between? Well, that's where the consortium blockchain comes in. You can think of this one as a semi-private club run by a group of organizations, not just a single one. So it's more decentralized than a private chain, but it's still way more efficient and controlled than a fully public one. Big platforms like Hyperledger and Corda operate in this space. Okay, this is the big question, right? If there's no one in charge, no boss, how on earth does this massive network of computers agree on anything? How do they all decide, together, to add a new block to the chain? Well, that's where the rules of the system come in. The magic ingredient here is something called a consensus protocol. This is basically the official rulebook that the entire network agrees to follow to validate transactions. It's the democratic engine that lets a system with no leader function securely and stay in sync. In short, this protocol is what replaces the need for that bank or central authority we talked about. Now, the two big ones you'll always hear about are proof of work and proof of stake. Proof of work is the original, used by Bitcoin. It forces miners to use massive amounts of computing power to solve a super complex math puzzle. It's like a huge race, and the winner gets to add the next block. But it uses a ton of energy. Proof of stake is a much greener alternative. Instead of racing, validators lock up their own crypto as a security deposit, or a stake. The more you stake, the better your chance of being picked to validate the next block and earn a reward. It's far, far more energy efficient. So, agreeing on transactions is one thing. But what if the rules could do more? What if we could build agreements right into the code that could just execute themselves automatically? And that is exactly what smart contracts are all about. These things are, frankly, incredible. They're basically just programs stored on the blockchain that automatically run when certain conditions are met. The best analogy is a vending machine. You put your money in, that's the condition, and the soda automatically comes out. That's the outcome. No cashier needed. And the benefits? Oh, they're huge. You get total automation, so you don't need a person to check things and enforce the rules. You get trust because the code is law. It's going to run exactly as it was written, no matter what. This cuts out the middlemen, which saves a ton of money, and it makes everything happen almost instantly. Okay, theory is one thing, but let's get to the fun part. Where is this technology actually showing up in the real world? Beyond just buying and selling crypto. Let's look at some awesome applications. Okay, let's talk healthcare. You know that pain of trying to get your medical records from one doctor to another? It's a nightmare, right? With blockchain, you could have a single, super secure patient record that you actually control. You could grant a new doctor instant, secure access. It would make healthcare so much more efficient and private. Or how about this one? You're applying for a job, and they need to verify your college degree. That process can take weeks. But with blockchain, universities could issue digital diplomas that are impossible to fake. You'd have a permanent, trustworthy record of what you've achieved that you could share and get verified in a second. And have you ever been in the supermarket, looked at a fancy product and wondered, is this really what it says it is? Supply chain is where blockchain is a total game changer. Imagine scanning a QR code on a bag of coffee and seeing exactly which farm it came from, the date it was harvested, and every single stop it made on its journey to you. That's real transparency. Okay, so it all sounds amazing, right? A solution to everything. But let's be real. The technology is still pretty young, and it's facing some pretty big hurdles. It's really important to have a balanced view here. It's super important to remember this isn't a silver bullet. First up, scalability is a huge issue. Many blockchains just can't handle the same fire hose of transactions that a system like Visa can. Then there's governance. There aren't really universal rules or regulations yet. Plus, trying to plug this brand new technology into old, existing systems, it's really complicated and really expensive. These are the big puzzles that developers are racing to solve right now. And all of this really brings us to the big, ultimate question. Is blockchain the next internet? A foundational technology that will change everything? Or is it a really cool but overly complicated solution that's still searching for the right problem to solve? The truth is probably somewhere in the middle. But one thing is for sure, the conversation about how we build trust in our digital world is just getting started.